All right, students, with this topic, we're looking at points of intersection between lines and quadratics. And this is a subpart of section 6.7 in your syllabus, which is using the calculator to solve equations involving combinations of the functions above. So this is above in your syllabus, so we're thinking quadratics and linear models and other functions that we'll look at later in the year. So today we're just going to look at lines and quadratics. So if we think about how many ways a line and a parabola can intersect, well, I'm going to start by drawing a parabola. And now if I think about adding in a line, so I've got a line that could just cut through. So now I've got 2 points of intersection. But also my line could be underneath, and then I would have no points of intersection. I could also have a line that comes along and touches only once and exactly once, and we call this a tangent line if it's got a slope to it, because I could have also drawn a flat line at the bottom, although that would be a tangent line as well. So tangent lines intersect at one point. Okay, so we can have 2 points of intersection, 1 point of intersection, or no points of intersection with a line and a parabola. If I think about 2 parabolas, so I could have a parabola that points down, a parabola that points up. So again, we could have 2 points of intersection. I could have 2 parabolas that point up with the same a value, and that would have no points of intersection. I could also make 1 point of intersection by drawing parabolas that have the same vertex. So that's one way. I could have also drawn that 1 point of intersection by having them go something like this. So it doesn't have to be vertex to vertex. Let's pretend like those were touching. So we could have had 1 point of intersection that way. And of course our parabolas could be on top of each other, making infinite points of intersection.